So basing upon molecularity, reactions are in three types: unimolecular reactions, bimolecular reactions and trimolecular reactions. First coming to unimolecular reactions. So in unimolecular reactions, only one molecule take part in the reaction. One molecule take part in the reaction. For example, decomposition of PCl5. PCl5 on decomposition forms PCl3 and Cl2. Okay. So only one molecule involved in the reaction. That's why molecularity of the reaction is 1. Okay. Then bimolecular reaction. Bimolecular reactions. For example, decomposition of hydrogen iodide. We get H2 and I2. So in this reaction, two molecules are involved in the reaction. Two molecules involved in the reaction. That's why molecularity is equal to 2. Okay. Then coming to trimolecular reactions. So in trimolecular reactions, 3 molecules involved in the reaction. For example, sulfur trioxide preparation. Sulfur dioxide reacts with oxygen, forms sulfur trioxide. So in this reaction, 2 molecules of sulfur dioxide reacts with 1 molecule of oxygen and forms 2 molecules of sulfur trioxide. So that's why molecularity of the reaction is 3. Okay. So molecularity, that is limited up to 3 and it does not exceed 3. Okay. Its limit is up to 3. Then let us take one example. Okay. For example, decomposition of hydrogen peroxide. Hydrogen peroxide decomposes into water and oxygen. Okay. So here, by seeing this reaction, you can tell its molecularity is 2. But its molecularity is not 2. Okay. Its molecularity, actually, its molecularity is 1. So this is the main reaction. And this reaction involves 2 elementary steps. Okay. So elementary steps having reaction mechanism. So this reaction having reaction mechanism and a reaction mechanism having 2 steps again. Okay. So first step in this, H2O2 on decomposition forms H2O and oxygen. Okay. And in second step, H2O2 with oxygen again, it forms H2O and O2. Okay. H2O2, H2O and oxygen. This is the first step. And this is slow step. Okay. Then in second step, H2O2 again with oxygen forms H2O and O2. And this is fast step. Okay. So what is molecularity? Number of atoms, ions or molecules which take part in rate determining step. That is molecularity. So rate determining step is slowest step present in reaction mechanism. So this is the slow step. And how many molecules take part in this reaction? Only 1. Okay. When the main reaction having 2 molecules of H2O2, but in rate determining step only 1 molecule of H2O2 take part. That's why its molecularity is 1. Okay. And some other reactions are there which having more than 3 molecules. For such type of reactions also, we use reaction mechanism to know the rate determining step which indicates its original molecularity. Okay. Next concept, half-life. Okay. So half-life of a reaction. So that is time in which concentration of the reactants becomes exactly half. Okay. So that is called half-life of the reaction. So exact definition for half-life is, half-life of the reaction is the time in which the concentration of reactant is reduced to half of its initial concentration. Okay. So half-life of the reaction is the time in which concentration of the reactants reduce to half of its initial concentration. Reduce it to half of its initial concentration. So that is half-life, which is indicated with the T half. Okay. For example, A to B reaction is there. Okay. Initially, A moles of reactants are there. Okay. And products 0 moles. After time T, okay, we get X moles of products. Okay. So, after the formation of products, number of moles left here is equal to A minus X. Number of moles of reactants left is A minus X. Okay. And initial number of moles are A. Okay. And initially number of moles of products is 0. After commencing the reaction, we get X moles of B. Okay. So, after the formation of products, X moles of products, remaining reactants are A minus X. Okay. For example, if T is equal to T half and X is equal to A by 2. Okay. So, X is A by 2. T is equal to T half. We can apply this half-life concept to zero order reaction and first order reaction. First, coming to half-life for zero order reactions. Okay. So, for zero order reaction, so rate constant for zero order reaction, we can give K is equal to X by T. Okay. So, this is the rate constant for zero order reaction. K is equal to X by T. What is X? A by 2. And T is T half. Okay. From this we can calculate T is equal to X by K. Okay. if T is equal to T half and X is equal to A by 2, if we substitute these T and X values here, we get half-life for zero order reaction T half is equal to A by 2K. Okay. So this is half-life for zero order reaction A by 2K. Okay. Next,